In this video, we're going to learn about two further statistical parameters, the range and the interquartile range. The range of a set of data is a measure of the difference between the highest and the lowest value. So we could write that as range equals the maximum value minus the minimum value. It doesn't have a symbol, we just call it the range. And it's a range of the data. So we're actually getting something that's connected to our variable, right? Whatever units our variable in, that will be the units on range. So my example here, these are years or ages of people in a room. Then my range will be also measured in years. So using this example to find the range, I just take the highest value, 30, and subtract the lowest value from it. So 30 minus 2 is 28. Since my units on these were years, because these were ages, then I'm going to say my range is 28 years. So it gives me an idea of the spread from the highest to the lowest, or what the difference is between the highest and the lowest. Thus, the range is one way of measuring the spread of the data. If you're comparing two sets of data with the same mean, for example, you might want to consider the range in your comparison as well, because maybe the data sets are not exactly the same, even if they have the same mean, there might be some other differences. To illustrate what I mean, let's consider these two sets of data. They both have a mean of 8. You can calculate it if you want, but you can just believe me. This set has a median of 9, and this set has a median of 8. So that already tells you that the data sets are not exactly the same. You could also look at mode, but that would be the same as the median. If we now also consider range, then we can see that data set 1 has a range of 10 minus 3. That's going to be 7. And data set 2 has the range of 9 minus 7, that's going to be 2. And there we see a big difference between the two. So if I was not able to see the sets of data and all I had was the statistical parameters, I can conclude that because the median and the mean are different in this one and the same in this one, data set 1 is probably going to have an outlier of some kind. There's going to be something different about it that's made the median quite a bit higher than the mean. Judging from the range, I can see that in the first data set, there's a lot more variability in the data. There's going to be pieces of data that are quite different from each other, whereas a small range is going to have less differences, so less spread. Whereas this is more spread out, this one has less spread. In real life, we wouldn't need to calculate statistics on small data sets like these. We can just look at it and see that without having to calculate any statistics. But we need the statistical parameters when the data set is too large to analyze easily. And so we're practicing it on smaller data sets so that we can see where the differences come from. So different statistical parameters give us a variety of information. And all this information can help us understand the variable we're trying to analyze. Range is useful, but there are other measures of spread that are even better, because range can be affected by outliers. We see that a little bit here. 3 is kind of an outlier, and it makes the range so much bigger. But let's look back at the original data set we were analyzing. We calculated the range for this data set earlier. That was 30 minus 2, so that's equal to 28. Now if we take the same data set, but add one more number, then we get quite a different range. So it's now 65 minus 2, or 63. So just by adding one large number, I've gone from a spread of 28 years to a spread of 63 years. In this course, we will look at two other measures of spread. The first one is the interquartile range, or IQR, and the second one is the standard deviation. The interquartile range is still a range, but it's the difference between the third quartile and the first quartile instead of the max and the minimum. And the standard deviation is a measure of the average distance away from the mean. We'll deal with the standard deviation in another video. For now, we're going to look a little bit closer at the interquartile range. The interquartile range is the difference between Q3 and Q1 rather than the max and the minimum, because then we compare the range of the middle 50% of the data rather than the whole set of data, and that's less affected by extreme outliers. Especially if it's just one outlier, it might only move just a little bit. And so we can write that formula or abbreviate that as IQR for interquartile range. There isn't really a symbol for it, but we often use that abbreviation. And it's equal to the third quartile minus the first quartile. We calculate the quartiles the same way that we've learned before, using the 5 data summary. With these two sets of data, the range jumps from 28 to 63, but the interquartile range jumps from 16 to 20. So here, quartile 3 will be 24. I'm not going to show you how to calculate that now. We've done that before. You can check it if you'd like. And quartile 1 is 8. And so this interquartile range is 16 years. And in the second set of data, the bottom quartile stays the same. It's still -8. But the upper quartile goes a little bit higher to 28 because now we're taking the average between 26 and 30 instead of between 22 and 26. So the interquartile range is now 20 years. So it does go up. After all, the spread is larger, but there would need to be more pieces of data with larger values like the 65 for it to jump as high as the range does. To summarize, we have two new statistical parameters. The range is equal to the maximum minus the minimum values, and the IQR is equal to the third quartile minus the first quartile, or we could say upper quartile minus the lower quartile. Remember that both need to take the same units as your variable. So in my examples, we were measuring in years, but if you were measuring things in centimeters, then your range would have units of centimeters, and so would the interquartile range. They're similar parameters, but the range takes the entire set of data, and the interquartile range takes the middle 50%. Remember, if we put our 5 data summary, we have minimum, first quartile, median, third quartile, maximum, or you can think of it as a box and whisker plot. And so the range finds this spread, rightly from the maximum to the minimum, and the interquartile range finds this spread. Yeah, both are a measure of spread, but this one is a little bit less affected by things that are on extreme ends of the data.